Hello, we are VR Conductor. Here's a quick overview of our project. We are creating a musical conducting simulator for training and practice and for educational purposes. We're using the HTC Vive for the VR interactions, using its controllers and its lighthouses in order to locate a person in real space. We are creating the instrument sounds using a library called Fluid Synth, and we are doing the 3D audio implementation in C++.
Our application will target three main user groups. The first two, musicians and music students, consist of people who are already conductors or want to learn how to conduct and are currently in a school setting. These user groups would use the application as a way to practice without having to gather a real musical group. The third group, music hobbyists and enthusiasts, are people interested in learning how to conduct and would use the application as a way to get started. Finally, we want to make our application accessible to the general public as well, for anyone interested in musical conducting. All of our user groups will probably have to share some common characteristics. One, an appreciation for music. Our application revolves entirely around music. Users not interested in conducting or music performance in general would probably not find much use in our application. Two, a basic understanding of rhythm. Conducting involves conveying a rhythm to the instrument players. Therefore, a user needs to have a basic understanding of tempo and how it is represented in the piece of music. 3. A basic understanding of musical groups. Coordinating a musical group is a conductor's main job, so a user will need to understand the different sections and their purposes in different kinds of musical groups.
In regards to the audio stimuli, these are the components that will make up this project. Synthesized instrumental pitches will serve as the notes being played by the instruments. Metronome-style clicks will exist as a sort of guide for those that wish to refine their tempo. And general sound effects, such as instruments moving around and just general batter around, will exist to kind of give a realistic environmental sense of the practice room. In regards to the 3D audio portion of this project, we're going to allow users to move around the instruments of their orchestration as they see fit. Pictured here is an example orchestration for a symphony orchestra. As you can see, the different instruments are grouped into different sections, and thus, for the user, they're going to have the ability to group these sections together and move them around as they see fit.
Our application will consist of two main components, an audio half and a visual half. On the audio half, our main inputs will be MIDI files and sound font files, which represent songs and the instruments that are played in them respectively. Both of these will be passed into Fluid Synth, an open source library that allows playback of these files with synthesized sounds. This will then be intercepted by our own tempo modulation, which will take input from the VR controllers to control the tempo as the conductor waves around his baton. This will finally be passed into audio processing, where we will apply our head-related transfer function based on the head-mounted display's position and orientation, as well as the instrument positions. All of this will. On the visual side, we will need to take the data from the head-mounted display again, and will then be represented on the head-mounted display in virtual reality. Our interface will be minimal. In virtual reality, a traditional heads-up display-like interface is not very useful. Instead, most of our functionality will be represented by its real-world imitation. For example, when selecting a song, the user will have a virtual book presented in front of them that they can flip through pages to select MIDI files. Similarly, for placing instruments in 3D space, will be an overhead view where they can grab the actual instrument sections and move them around. Lastly, we will want to include a particle trail as the user waves the conductor's baton around so that they can visualize what shapes they are making as they conduct, and all of this will be allowed to be replayed so that conductors can review their performance.
So far, our progress on this project has been considerate. In the audio portion of the project, we have a minimally complete solution, such that in its bare necessity, it addresses the basics of this application. We are doing this by using Fluid Synth in order to synthesize the sound and also read in the MIDI files. And we are implementing 3D spatialization by using HRTFs with distance attenuation written in C++. On the graphics end of this project, we are currently working on a solution. We are using OpenGL to render everything, and we are using a custom framework in order to allow for more flexibility in development. In regards to our experimental procedure, these are the steps that we will take. We will begin by allowing the user to be fully immersed in our graphics environment using a head-mounted display like the Vive. Once that is set up, we will play a metronome-style click in the background and ask the user to conduct to that tempo. Once we read in the BPM that our application registers from their conducting, we will compare those values against the BPM of the metronome clicks and calculate some sort of error or offset based on that in order to test our design.